This is the last video that we're doing for this chapter on dilations, and for this video we will discuss the effects of scale factor on perimeter and area. We know that similar figures can be created when the original figure is multiplied by scale factor, and we've been talking about that for the past two lessons. Scale factor can be found if you write a ratio with the corresponding sides, and the ratio would be your dilated side over the corresponding original side length. So you can say new over old. And I like to say N over O. No, new over old. Okay, so we're going to first discuss the effect that scale factor has on perimeter. Remember, perimeter means that we're adding up all of the sides. So we've already discussed how to find the scale factor, and we already know how to find perimeter. What I want you to do is to pause the video, and for A, B, C, and D, I want you to find the perimeter and scale factor for each. So you're going to find the scale factor for A, scale factor for B, scale factor for C, and the scale factor for D. Let's look at D real quick. D is a word problem. So Heidi has a fence around her garden which measures 10 feet by 12 feet. She wants to enlarge her garden by increasing the dimensions to 15 by 18 feet. How many times longer will her new garden be? Now, I know you may think that you don't need to do all of the steps that we're doing for A, B, and C, but we actually do. The one thing that's missing is that we do not have a picture. So please, for D, let's go ahead and draw two rectangles. The first one would be 10 feet by 12 feet. And the second is going to be a little bit larger. And we have 15 feet by 18 feet. So now, pause the video, find the perimeter and the scale factor for each of these. So each figure should have its own perimeter, but there will be one scale factor for A, B, C, and D. So each one will have their own scale factor. Pause the video now. Okay, so hopefully you have found the scale factor and you found the perimeter for each. So looking at A, you should have a perimeter of 14 for the first one and 28 for the second. B, you should have a perimeter of 20 for the first and 10 for the second. C, you should have you should have a perimeter of 36 for the first and 12 for the second. And on D, you should have a perimeter of 44 for the first and 66 for the second. On A, your scale factor should be 2. B, your scale factor should be 1/2. C, your scale factor should be 1/3. And D, your scale factor should be 1.5. Okay, so if you did not get the same things that I have, I do want you to pause the video at this moment and make corrections. Also, if you're looking, you can see that I have work. It doesn't take a lot for you to show work, so make sure that you do have your work shown. Okay, so now let's take that information and we're going to put it into the table. If you notice, you need the scale factor, then you need the original perimeter, the dilated perimeter, then you're going to create the ratio with the dilated perimeter over the original perimeter, and then you're being asked, how does the scale factor compare to the ratio of the perimeters? I mean, are they the same? Is it different? And then we're going to use the scale factor to find the new perimeter. So let's go ahead and complete the table. So if you would, pause the video, unless you already have the table completed. But if you have not completed the table, please pause the video and take the information from the images and put them into the table and then restart the video. Okay, so hopefully at this point you do have this piece of information, so let's just see how they compare. Well, when I compare the scale factor to my dilated perimeter and original perimeter in its simplest form? Well, they are the same. And if I go through and look at all of them, I will see that they're all the same. So the last box asks us to use the scale factor to find the new perimeter. So what that means is I'm going to take my scale factor of 2, and my original perimeter is 14, and I'm going to multiply those two, and when I do, I get 28. Guess what? That is the same number that I have for my dilated perimeter. So if I go to B and take 1/2 and multiply it times 20, well, 1/2 of 20 gets me 10, and that is the same thing that I have for my dilated perimeter. Moving on to C, 1/3 times 36, and 1/3 of 36 is 12. And on the last one, if I take 1.5, multiply it times 44, it will equal 66. So, two things that you should have learned from this video, this piece on perimeter. You should have learned that the scale factor can be found by finding the ratio of the corresponding sides. So that's one way we can do it. Or by finding the ratios of the perimeters. So again, if you're working with perimeter and we're talking about scale factor, we can see from our table that the scale factor in the perimeter of the dilated and the original is going to be the same. Also, the scale factor tells us how many times bigger or smaller the perimeter or the corresponding sides are for the new figure. So again, the scale factor applies to the perimeter and it also applies to the new figure. Now, let's turn the page over and discuss area. So on this side, if you notice, we have the same images until you get to D. D is the only thing that's different, and I'm going to work with you with D quickly so that you can use perimeter to help you to find the side lengths, and then you can find the area. Now, so for A, B, and C, you should notice that we have the same images, which means they have the same scale factor as what we just discussed with perimeter, so you don't have to worry about finding the scale factor. You just need to find the area of each piece. C, let's look at real quick on C. One thing I like about it is that they gave us angle measurements. If you notice, we have 37 degrees and we have a 90-degree angle, and they're in the same location on the old image as in the new image. Another thing that I like about C is, if you notice, they named the vertices A, B, and C, and then on the second one, they named the vertices E, F, and G. Well, because EFG comes after ABC, then we know that that second image is actually the new image and the first one is the old image, because ABC in the alphabets comes before EFG. Now, let's look at D, and then I want you to pause the video and find the area for each of the other figures. So on D, if you notice, they gave us side lengths on the first one, but they gave us a perimeter on the second one. So in that case, what we have to do is use the perimeter to help us find the scale factor so that we can get the side lengths of the second image. So for the first one, the perimeter would be, well, 8 plus 8 is 16, and 3 plus 3 is 6. Well, 16 plus 6 is 22. So I know my perimeter is 22. Well, if I take the perimeter of my new, which is 66, put it over the perimeter of my original, or my pre-image, which is 22, then I get a scale factor of 3. So remember, for it to be a similar figure, that means that each dimension of my original had to be multiplied by the same constant or by the same scale factor. So in this case, it's 3. So I'm going to take my side length. So for example, 3 times 3. And when I multiply it, I get 9. So my new side length would be 9. Then I'm going to do the same thing with my 8. If I take 8 times 3, multiply it, I get 24. So I know my new side length is 24. Now that I have those side lengths, 9 and 24, I can find the area of the last one and I can find the area of the first one. So pause the video now and find the area of each shape and then start the video back up to see if you are correct. If you notice, I wrote my area information inside of the images because they will do that a lot. You know, sometimes on tests, they will put the area information on the inside of the figure. And so that's one of the things that we need to be paying attention to. Now, hopefully you have the same thing I do. For the first one, the area is 12 for the first one on A. And then the second one should be 48. On B, you should have 16 for the first one and 4 for the second one. On C, you should have 54 for the first and 6 for the second. And D, you should have 24 for the first and 216 for the second one. Now, let's take this information and put it in our table. So if you would, pause the video and put the information into the table. And I'm going to help you out just briefly with the scale factor part, because remember I told you that if you look at A, B, and C, the side lengths did not change, so the scale factor is still the same. The only thing that the scale factor changed for was D, because D was a different problem for the first on perimeter as when you compare it to this one on the area. So then go through and put everything else in. Alright, so up to this point, hopefully this is what your table looks like. Now, when you came to your dilated area over the original area, you should have divided to put it into its simplest form, and you should have 4 for A, you should have 1/4 for B, you should have 1/9 for C, and you should have the number 9 for D. So in the next column, we're being asked, are the scale factors the same? Are they equal? Well, if you look at it, no, they're not. They are two different things. When you compare the scale factor, just the original scale factor, to the area ratios, they are not the same. So no, they are not the same. But let's talk about them, okay? So let's look at them. If you notice, when you look at the scale factor for A, well, it's 2. And when you look at the ratio for the area, you see that it is 4. Well, 2 times 2 gets you 4. If you look at B, we have 1/2. And for the area, we have it as 1/4. Well, 1/2 times 1/2 is equal to 1/4. So let me do some notes here. We have 2 times 2, which gets us 4. Then we have 1/2 times 1/2, which gets you 1/4. And we have 1/3 times 1/3, which gets you 1/9. And then, of course, we have 3 times 3, and that gets us 9. So if we're thinking about the relationship when we are comparing the dilation to the original, the ratios of the areas is the same as the scale factor squared. And I'm going to put that in a green color so it'll be easy to see. So the scale factor squared. So the new area can be found by the scale factor squared times the original area equals the new area. So again, the new area can be found by squaring the scale factor first, because that's what the order of operations say we will have to do, exponents first. and then taking that number and multiplying it times the original area, and you will have your new area. So similar figures are proportional, and the ratio of their areas is proportional to the scale factor squared. And this is very important that we learn this information, and we will work on it a little bit in class. Everybody, if you have any questions, please write them down, and we will address those questions when you come to class. Have a great evening. Bye-bye.